Hi everyone, I welcome you all for my mathematics class. This is an assignment. Today I have taken a problem in assignments. What is the meaning of an assignment? Assignment means here from this point of view, what I am going to teach you, it is nothing but assigning a job to a person or machinery. That's all. See, it does not literally meaning an assignment. It means an assignment in the sense that assignment of the jobs to machineries or persons in such a way that the assignments result in minimization of expenditure on the persons or the maximization of the sales because of the efficiency of the person who are salesmen. Can you understand? So what I mean is, but actually speaking, this assignment problem, I mean, this is assignment problem. It is assignment problem. Assignment problem is a minimization problem. Is a minimization problem. And here the meaning of this assignment is, as I told you in the beginning, that assigning. For example, here is a problem that I have taken. Here you see that there are 5 jobs are there and there are 5 machineries. Now that in the matrix that you find, the elements inside the matrix refer to the minutes of time taken for completing the job by machinery A, B, C, D and E. For example, you see that if this third job is given to machinery C, it takes 33 minutes. Whereas if the same job is given to A, it takes 41 minutes. So this is the meaning of this particular matrix. Now you see that here, for example, if you take this job 1, it can be given to any of these 4 machines, and you can find that if one is given to A, it takes 32 minutes, whereas B takes 38 minutes, C takes 40 minutes, D takes 28 minutes and E takes 40 minutes. Our common sense tells us that it is better that you give A to job 1 to machinery D, because it takes the least time amongst all. So it is 28 minutes. So you see that likewise you can judge, but that judgment, what do we want in this problem is that you assign it in such a way that the overall cost, overall time taken, not cost, overall time taken is kept minimum. See, what is our aim? The objective of this assignment problem is that you assign the jobs to the machineries in such a way that the overall time taken is kept minimum or the overall cost is kept minimum. So this is as if you take this as a minimization problem. And so this is the idea behind. So it is not concerning only one job 1 to D. If you take job 2, it also sometimes it may so happen that you may have to give the 2 jobs to the same machinery, that is as per the elements given here, but that should not be done, because the assumptions that we make is that 1 job 1 person, 1 job 1 machinery. 2 jobs cannot be given to a single person, or 1 person cannot do 2 jobs. So it is so. So you see that with that assumption or condition, I should say, we should do this problem. So here our idea is to assign the jobs to the missionaries depending in such a way that the overall time taken is minimum. And this assignment problem is a linear programming problem, because the assignment problem is given like this. It is minimization of z. Z is the objective function in the sense that it may be referring to cost, or it may be referring to time, or it may be referring to even profits and income. So it may be like that. So depending, so if it is minimum, it is definitely a cost or the time. If it is maximum, it we can take, but normally we take only minimization of z. So this is given as, see, this will resemble I is equal to 1 to n and j is equal to 1 to n. It is Cij Xij subject to sigma of I is equal to 1 to n, Xij is equal to, it is 1, and sigma of j is equal to 1 to n, Xij is equal to 1, and Xij is equal to 0 or Xij is equal to 1. So you see that this is a linear, you see that it is linear programming problem, because none of the term is, they are linear, that is no square term is taken. So you see that this is a linear programming problem, minimization of z subject to the condition that Xij. See, it has got a very wide meaning in this, about which I will, if at all I should explain more on this, means I should take a separate class for that. I should definitely take a separate class for that. But I will tell you in some way here, connected with this problem. You see that, first of all, I told you that one problem, one missionary. In the sense that one job, one person. That means if you have 5 jobs, there should definitely be not more or not less than 5 persons. In the sense, the number of jobs is equal to number of missionaries. That is the one. And therefore, here you see that there are 5 jobs are here, therefore 5 missionaries. Now that here, therefore this is a balanced problem. So it is said to be a balanced problem only when the number of missionaries is equal to number of jobs, or number of jobs is equal to number of persons. So you see that now this job 1 can be assigned to any one of these missionaries only. If it is assigned to a missionary, take the value as 1. If it is not assigned to a missionary, take it as 0. For example, let us suppose that this missionary 1 is assigned to D. That means what? Xi, see, I will take like this. This is called your assignment. 1, 4 is equal to 1. What does it mean? This is called your assignment. X refers to assignment. Assignment of first job to fourth missionary is 1, means it is assigned, and that is that job will be done by the missionary D. But if it is 1, 1, x11 is 0, x12 is 0, x13 is 0, x15 is 0. So you see that x14 is equal to 1 means rest of them will not do the job. In those places the assignment is 0. If you take the second one, therefore if you add this is 0, this is 0, this is 0, 1, 0. So don't take these values. You have to take only the assignment value. Assignment value can be 1 or 0. 1 means assigned, 0 means not assigned. So here 1 is not assigned to A, 0. 1 is not assigned to B, 0. 1 is not assigned to C, 0. 1 is assigned to D, 1. 1 is assigned to E, therefore 0. So you add everything, it will be equal to 1. You see that? That is what I have written here. Even if you go by this, here you see that if 1 is assigned to D, 1 will not be assigned to any other missionaries. And this D is now assigned to 1, therefore D will not be assigned to any other missionary jobs. D is assigned to job 1 means it will not be given 2, 3, 4 or 5. So here you see that 1 will be here, rest of the place is 0. So likewise you will find that 1 here, 0 here. Suppose 1 is here, here everywhere 0. Suppose if you find 1 here, here 0, here 0, here 0, here 0 and above also 0. So at any column or any row, if you make the assignments, you see that sum of the assignments, what I mean is, see, this is called a sum of the assignments. Sum of the assignments will always be equal to 1. And another condition is non-negative condition, xij is equal to 0 means what? That ith job is not given to jth missionary. Xij is equal to 1 means what? Ith job is given to those things, and this is true for all ing. For all ing. For all ing, this is true. So this is a linear programming problem. Now, here you see that, so this is very, very important. This is very, very assignment problem. This is very, very important. And you see that this is a linear programming problem, and this is here xij, as I told, xij is equal to 1 means ith job is assigned to jth job. Ith job will be done by jth missionary. If xij is equal to here you see that xij is equal to 0 means ith job will not be done by jth missionary. And row, sum of the assignments in a row is equal to 1. Sum of the assignments in any row is equal to 1. Sum of the assignments in any column also equal to 1. So this is the assignment problem, and the condition is that one job, one missionary. Therefore, the number of jobs must be equal to number of missionaries. If it is not so, you see that it is said to be an unbalanced problem. You have to balance first and then solve the problem. But here you see that here it is a square matrix. The number of jobs is equal to number of missionaries, and therefore this is a balanced problem. You can go ahead with your method of doing it. So I will write here. So let us try to solve this. So you have to find out the proper assignment. Assignment means what? Solve means solve assignments. So what is the meaning of this? Solve the assignment problem means finding the proper xij's. Finding the proper xij's is called what? Proper xij's in the sense that those xij's which will minimize the cost or minimize the time. So this is what we are going to do. So it is ij. Now let us start doing this. See, this is what I am going to do is called your Hungarian method, and this you see that we will use Hungarian method. The method that I am going to use here is Hungarian method. This is your Hungarian method. Now what I just closely watch, because I will not write the full thing, but I will be repeating. Closely watch what I teach you. So you see that if you are given like this, say I tell you choose the minimum of the row elements and subtract it from every other element. I know that subtracting a constant or adding a constant in any row or column will not change the assignment of the problem. See, there is one particular assignment is there for this problem. If you add or subtract constants in the rows or columns, it will not alter the assignments. Therefore, you can always go for what? You can go for subtraction of a constants from rows, and even you can add. So you see that here, you see that we are getting here. Now this is equal to this one you can write. Now choose the minimum of this. So your minimum of this 28, take this 28 from every element. So it is 4, and it is 10, and it is 12, and this is 0. So I have taken this 28 from this. So it is 4, it is 10, it is 12, and this is 0, and it is 12. Then likewise you go for this. Here it is 21, so this is 19, and this is 3, and this is 7, this is 0, and this is 15. Then go to the next one. Here it is, the minimum is 27. 27 plus 4 is 31. 4 first 10, 0, then this is 6, and this is 3, and this is 10. And go to this. Here 22 is the minimum, so 22 minus 22 is 0. Then this is 16, and this is 19, and this is 14, and this is also 14. Come to this. Here the minimum is, here it is 33. So 29. 29 plus 4, 29 plus 4, 33. It is 11. It is 6. It is 29 plus 10. So this is, so I have subtracted. So I have chosen the minimum, and I have subtracted from every element. Check whether, now you see that every row will have a 0. Every row will have at least a 0. I mean at least a 0. Then check every column. If there be no zeros, then choose the minimum in that column and subtract from every element in that row. See, for example, here this is having, so 2 zeros are there, leave it. 1 0 is there, don't worry. Now you see that this does not have a 0, so I have to do something. Here here 0 you have got, so don't worry. And here you see that it does not have a 0, so you have to bring at least 1 0. So you see that here I do like this. 4 is, see here, don't worry about this. It is 4, 19, 14, 0, 0. Here this 10, 3, 0, 16, and 4. Here you see that your 6 is the minimum, so subtract it. So 6 plus 6 is 1, 0, then 13, and this is 5. And here you see that 0, 0, 3, and 14, and this is 6. Come to this 10 is the minimum, so it is 2, it is 5, it is 0, it is 4, it is 0. Now you see that I am able to bring in every row and column to have at least 1 zeros. Then you go for now assignments. Assignment in the sense, if you bracket a 0, it is called an assignment. So let us start doing the assignments. Now you see that here 1, 2, 3, 4, 5. 5 jobs, A machinery, B, C, D, E. Now you see that there is only 1 0 here. So this job 1 can be assigned to D. So what I do here is that, see, I bracket this. I take this. See, you see that this is bracketed because that is the only 0 available in that row. So you just bracket this. It means that this one job is now, as per present condition, it will be given to D. First job will be given to D, and it means that it may be the minimum. It may be the minimum in that particular row for that job. Now when you do this, cut or mark, that is put a into mark for all these 0 on the left, that is up and down. Here you see that here there will not be any zeros. Then you see whether above or below, if there are zeros, just mark them. Mark them means put a into mark. You know what is the meaning of why we mark put it? So it means that even because zeros are used for bracketing, in the sense that for assignment. See here this 1 is already assigned to D. Here there is one more 0, that there is a chance that you may assign this D again to D2. So in order to avoid any such mistake coming, it is you mark this 0. It means that here afterwards this is assigned, means no, in this D will not be given to any other jobs. D machinery will not be given to any other jobs. In order to avoid such mistakes coming, you see that if you find any zeros below or above, mark them, in the sense put an into mark, so that you are safe that this machinery is given to only this job. That is the meaning of that. Okay. Now let us come to this. Now what is that you find here? So in the second row there is no zeros which is open. Third row, if you go, you see that here there are 3 zeros. Which one to assign you do not know, so you leave it. Then come to this, there is only 1 0, so you see that assign this. As I told you, if you find any zeros up and down, just mark them for the same reason. Now this job, fourth job, now you see that fourth job is given to A, so this A should not be given to any other thing, and this A machinery should not be given to fifth job. So in order to avoid that, you see that you are marking it. So you see that now you come to the last row, there is only 1 0, so just put a assignment, and simultaneously if you find any zeros up or like that, cut it. You know what is the meaning of why you cut this? Because you have assigned the fifth job to eighth machinery. The eighth machinery should not be given to any other job. By mistake also you should not give to 3. That is why we mark it. That is the meaning of that. Now having completed row wise assignment, you just look for column wise assignment. You go to the first column, this is assigned, this is marked, don't worry about that. Come to the second column, see there is only 1 0, so you assign this. Simultaneously what is that you will do? Simultaneously, if there be any zeros, just cut it. If there be any zeros, cut it. Now that means what? This third job is assigned to B, and you go to the next column. Here there is 0 is assigned, this is marked, so okay. Here also. Now you just see whether all the jobs are assigned. Now A is as 1 is assigned to D, 2 is not assigned. See, you see that you have not assigned 2 to any machinery. The job 3 is assigned, job 4 is assigned, job 5 is assigned, but 2 is not assigned to A. That means the optimal solution has not been obtained. Now what you have to do is, so you have to do something. So what I do is, see, closely observe what I tell, because I don't write. You just observe what I am talking closely, then only you will be able to do. So you see that. So you see that now the assignment is not complete, or it is not optimal. Second job is not assigned to any machinery. So tick the row which does not have an assignment. Now you see that bracketed 0 will tell you that it is an assigned, the job is assigned. But here you find that this D, job 2 is not assigned to any machinery. So tick that. Then move along this row and tick that column which has a marked 0. You just see that, move along this row and tick the column which has a marked 0. This is a marked 0, so you tick it. Then move along this column, tick that row which has a assignment. Move along this, there is assignment, so tick this. So this process has to be repeated. You have to repeat this process unless you find that it is properly ticked. See here, you see that this does not have. By chance, if you tick here, there is one marked 0, means what? You have to tick this column, go over this, tick the row. This must be continued. This must be, unless and until you don't, it could not be done. You cannot extend it. You have to do it unless and until you cannot extend further. Okay. Now, so you do like this. Then, so I'll repeat this. Choose the row which I choose. Tick the row which has no assignment. Move along that and tick the column which has a marked 0. Move along the ticked column and tick the row which has an assignment. Repeat this process till we cannot extend further ticking. So you see that if this is done, you see that now no more, because you tick this, there is no marked 0, so you stop there. Now after then you draw thin lines on the unticked rows. So you see that this is an unticked row, this is an unticked row, and this is an unticked row and ticked column. So you form this ticked column. So how many lines are there? 1, 2, 3, 4. There are 4 lines are marked, and that how many assignments are there? 1, 2, 3, 4. So the number of lines you draw must be equal to number of assignments. So you draw like this. After then, choose the minimum of the open numbers. So these are all open numbers. Can you see this? These are all open numbers, and these are all what? The line run over the numbers. So you see that these are all open numbers. Choose the minimum of this. Which is the minimum of this number? Choose the minimum of this. Add this number with subtract this number with the open numbers, and add with the numbers at the intersection of the lines, horizontal and vertical lines. I'll repeat this. Choose the minimum of the open numbers and subtract that number from open numbers, and add with the numbers at the intersection of the horizontal and vertical lines. Now someone who is watching will be able to tell me this. So what is that you are getting? It is 3, it is 9, and it is 5, it is 0, it is 1. Then it is 18, and it is 2, it is 0, and don't do anything. It is 0, and it is 4. Next is, see it here, you see that the line runs over. So don't worry about that. So 0, 0, this is at the intersection, 3 is at the intersection, so it is 4, it is 0. Then here 0, 16, and it is 13, and it is, so you see that this is 14, and 14 plus 1 is 15, and it is 4. Come to the next one, 0, it is 4, 5, this is also at the intersection, 6 plus 1 is 7, and this is 0. So I'll repeat this again for the benefit of those who are watching and not able to understand. So what is that? You give an assignment like this, go row wise assignment and then column wise assignment. When you assign, when you bracket a 0, the zeros below and sidewise should be marked, for the reason that that particular job cannot be given to any other missionary, or that missionary cannot do any other job. And you just finish off this. If every job is given to one missionary, the optimal solution is obtained. If there be any job which is not assigned to any missionary, it is the optimality has not been reached. So what we do is, you just tick that row which has no assignments, move over that row and tick that column which has got a marked 0, and move over this marked column and tick the row which has an assignment. Repeat this process until you just no more, that is, it cannot be extended further. That means what? If you tick it here, there must be one more marked 0, then you have to mark that column. So that process must be continued till you see that it cannot be extended. Now then, after then, you just draw lines on the on the rows which are not ticked, and lines on the columns which are ticked, and the number of lines will tell you the number of assignments, present assignment. Then you choose the minimum of the open numbers, subtract it from all other open numbers, and add with the number at the intersection of the horizontal and vertical lines, so that you are getting a new matrix like this. Now you start your assignments again. Now you start the assignments. Now come to the first row. You have got 0, only 1 0. Simultaneously cut this. Come to the second row. There is only 1 0. Mark this. Simultaneously cut this. Come to the third row. There are 2 zeros are there, so you cannot do anything. So leave it. Then come to the fourth row, so you have got this, so simultaneously cut off this. Come to the fifth row, so you see that here you have got here this one, so simultaneously cut off this. So row wise it is over. Come to the column wise. This column you have got 0 assigned and 0 is marked. come to this, only 1 0 is remaining. So assign this and come to this. Here you see that it is marked, and here you see that yes, and here you see that here it is 1 0 marked and 1 0 assigned. So you see that this job 1 2 3 4 5, this is A, B, C, D and E. Now job, machinery, time in minutes. See, first job is assigned to your D-th machinery. Second job is assigned to C-th machinery. Third job is assigned to B-th machinery. 4 is assigned to 8th machinery. And 5th job is assigned to E. Now what is the time taken here? First job is assigned to D. How many minutes? 28. Second job is assigned to C. So 28 minutes. Third job is assigned to, first job is assigned to D. Second job is assigned to C. Third job is assigned to B. Where is B? It is 27. Then fourth job is assigned to A. So it is 22. And fifth job is assigned to E, which is 39. So you see that if you assign the job in this way, you will get the job's overall time taken will be the minimum least possible 1 hour. So you see that what is that assignment? Say assignment is what? Here x1, see this is x1 4. x1 4 is equal to 1. And x2 3 is equal to 1. And x3 2 is equal to 1. And x4 1 is equal to 1. And x5 5 is equal to 1. So you see that 1 2 3 4 5. You see that that means what? Here this job is assigned means this is 1. All other places 0. So if it is assigned, it is 1. If it is not assigned, the value is 0. So that is why we say that what? Sigma. See, that means what? Here you add everything. Here it is 1. All other places was 0. So if you add, you will get 1. Likewise here, everywhere 1. That is why that condition is given. Sigma of I xij is equal to 1. And sigma of j xij is also equal to 1. And that is C, you can very well understand. So this means that the jobs are assigned. And this is the way we do it. I will do the same problem tomorrow with respect to profit making, in the sense that here you see that the 5 jobs are 5 persons you can take, and these are the places where the salesman will will be doing their sales. The salesman will be doing their sales, and this may refer to the profit. Now the question is how cleverly you will assign the cities, the places to the salesman, so that the company earns the maximum profit. Are you able to understand? That problem I will take in the next class. So you see that here you must write this, that min of Z is equal to minimum of Z is equal to 144. This Z is the time, overall time taken. See, time over the objective is overall time taken for doing the job. Overall time taken, see, overall time taken for doing the jobs. That means what? You cannot consider 1 job or 2 jobs. You take collectively, you take all the jobs and assign the persons so that the overall time taken is minimum. So this is how we do it. And let me, as I told you, I'll treat it as a maximization problem. This is minimization. I will teach you how the maximization problem is done in my next video. Thank you.